Alright, so today we're going to be talking about graphing absolute value functions. And that is our goal today, is to graph absolute value functions here at the bottom. So let's all read the objective. Nice, loud, ready, and begin.
I will graph absolute value function.
Good, okay. So can we pull out that the worksheet I did with all of the different types of graphs? Remember that thing we did a week ago? It was like your resource. It's that note page that I gave you. It had like linear, quadratic. The one right before that one. That one, yep. And you'll find the one that says absolute value. You'll see that. Okay. Review it. I want you to focus on linear. No, it's the one right before that one I gave. Can I see that one? This one? This is the one, kids. Look for the one that says linear. There's only one linear, which is at the top. Okay? And then focus on the one that on the back says absolute value. Okay? Yep. Okay, keep that handy. Those are the two concepts we're looking at. Linear we've looked at. You've looked at it when you were an 8th grader. You also looked at it when you were a freshman here. And you should have looked at a little bit geometry. Hey kids, quiet down. You should focus. You only have so many minutes in here, and this is like the most meaningful time for you to learn. Okay? So we're talking about absolute value. So we're going to kind of review what we talked about before. These are the steps, so if you're on the video, you should pause the video and write these down. Okay, so recall slope-intercept form of a line. When I'm talking about linear, this is the slope-intercept form, y equals mx plus b. Does this look familiar to everyone from before? This is nothing new, right? M is your slope, b is your y-intercept. So when I do this first problem here, when I graph it, y equals 3x minus 2, what's my slope on this one, everyone?
3.
Good, so our slope is 3, right? And then what is my y-intercept?
-2.
Good, so when I talk about my slope, it's going to be 3 over 1. -2 is my y-intercept, so I go to -2. And then I go up 3, and then over 1, plot a point, and I do this again across my graph, plot a point, right? This is nothing new. And then we draw a line.
Ooh, that's a good line.
It's all right, okay? That's a little off. And that's our line, right? Remember doing this freshman year? We did this last week, okay? What about the second one? What's my slope on the second one, everyone?
-1/2.
-1/2, and the y-intercept is 3, so we're going to go to 3 again. But instead it's going to be -1, and then over 2. It's your slope, down -1, run 2. Down -1, run 2. And we do this across the whole graph, right? Oops. And again, you could draw a line across through all of these points that are there. Okay? Linear. Good? So the two things in linear that you have is a slope and a y-intercept. What do you notice on the paper I gave when you graphed absolute value? What did you notice when you graphed it on decimals? What does it look like? Does it look like a line, or what does it look like? It looks like a V, right? So today we're going to look at absolute value graphs. They're going to look like a V. Okay? Do lines look like a V? No. But do lines have a slope? Does the absolute value have something similar to a slope? Yeah. Yeah, it kind of has two slopes. And what do you notice about absolute value signs or absolute value graphs that are similar to your face? What's similar about them? They're symmetrical. Do you notice that on your graphs? Okay, good. Okay, kind of like bringing a lot of stuff together. Hopefully your face is symmetrical. If it's not, well, there's surgery for that. No, I'm just playing. Here we go. You're special. Okay. Just playing. Okay, so let's just do this on any graph. You could graph using a table, eyes up here. So this is an absolute value equation, y equals to absolute value of x. This is the most basic form, and we did this on your paper, but let's just do it again. So we could make a table, inputs. Here we go, inputs. Okay, so what's the absolute value of -3? What's the output? 3, good. What's the absolute value of -2? 2, good. What's the absolute value of -1? Absolute value of 0? Absolute value of 1? Absolute value of 2? 2. You see how it's always positive? And then if I were to plot these points, it would look like so. Right? And if I were to draw a line through these, you'll see that it creates a V, right? And one of the other, do you notice how these points are symmetrical? Do you notice how this point is symmetrical with that point? Do you see that? This one is symmetrical with that point?
Yeah.
Yes? Or that this next one is also symmetrical? What is this point here called, like in geometry? What was it called when they came together, like an angle? What was that point called, or like on
Vertex.
vertex? Good. Okay. Did y'all hear that? Vertex. Okay. Some key things. Here we go. So numbers 1 and 2. Let's eyes up here. So numbers 1 and 2. It says graph. So just by looking at this, what kind of equation is this?
Absolute value.
What's the clue that it's absolute value?
The lines on the outside.
Good. The absolute value lines are covering the x. Do y'all see that? Yes? Okay. So what do you predict the shape should look like?
A V.
What should the shape look like, everyone? Oh, good. It should look like a V. Good. Okay. These are things you should just kind of, just by looking at it. Okay. Today it's kind of like I'm giving you a little bit of a hint, but when we do this, you should know it's absolute value. Okay. So when we do an absolute value graph, this is what it should look like. We need to know we first need to start off with the standard form of the equation, which is y is equal to a times the absolute value of x minus b closed absolute value plus c. Okay. And I asked myself, does my original problem look like the standard form? Well, kind of, but no. So I kind of have to identify some things. The first thing I want to identify is a. A is the coefficient in front of the absolute value sign. Is there a coefficient in front of the original problem here? Yes or no? No, but I could assume there's a coefficient. What coefficient can I assume is there? A 1, good. So there's a 1 there. So it's like saying 1 times this. So a is going to be equal to 1. Okay. So since a is equal to 1, I could say that, well, I'll just leave that there. Then I want to figure out what b and c are. Well, this is saying x plus 3, and I know I could rewrite x plus 3 as like x minus a negative 3. Right? Isn't x plus 3 the same thing as x minus a negative 3? And this follows my format here. So our b is negative 3. And then our c, wait a minute, there's no c there. What number represents nothing?
0.
0, right? There's nothing there, so c is 0. So we have some information here. So the b and the c are very important. They give us the vertex of the graph. So since b and c are known, we could say our vertex is negative 3, 0. And we would plot that as our vertex, negative 3, 0. Okay? Then I want to use a. A is 1. A is like my slope, okay? So there are 2 slopes you need to know, a and negative a. So our a is like saying positive 1, which we can make a fraction by putting it over 1, okay? Eyes up here. And then there's negative a, which we're just going to take our same number of positive 1, but we're going to make the denominator negative 1. Okay? We just make the denominator negative 1. Okay? So I'm going to go from I'm going to put my slope now. Our first slope was a. We're going to go from the vertex and we're going to put our slope down of 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. And basically what I'm doing is I'm using my slope of a down here. Up 1 over 1. Y'all see that? Good? Then we're going to go to negative a. We're going to go back to the vertex and we're going to use the second slope I have, which is up 1 over negative 1. Okay? So back here at my vertex, I'm using negative a now. Okay? We're going to go up 1 over negative 1. Up 1 over negative 1. Up 1 over negative 1. Do y'all see that? Do you notice how the points are symmetrical across the vertex? Do y'all see that? Okay, good. These are very basic details. I just want to make sure you get it right. Okay? Then we just draw a line showing the graph. And we are done. Okay? And we're going to draw arrows because these actually go on forever. Okay? Does that make sense, everyone? So that's number 1. Yes, Victor?
How come for A where there's no number it equals 1, but for C it's 0?
Because A represents a coefficient that's in front. That's a really good question, by the way. The coefficient in front of like a parenthesis or absolute value, if there isn't one there, we assume it's a 1. Okay? Because we're saying there's one coefficient of, or there's one of this package of absolute value or this parenthesis. Okay? When there's a blank space and there's nothing there, the number that represents a blank space that's not a coefficient is 0. Does that make sense?
Yeah.
Okay. Yes, sir.
The second part, is that x minus b or x minus 6?
X minus b. Uh-huh. Yeah. Okay, so let's do this again. Number 2. Watch me do number 2. Y equals 2 times absolute value x minus 1 plus 3. What kind of equation is this, everyone? Again? Okay, so it should look like a what, everyone? A v. Good. Okay, I'm going to go a little more quickly now. Okay, so again, I'm checking to see if this is in the right form. Y is equal to a times x minus b plus c. Okay, so hey, look at that. A is equal to 2. Nice. B is equal to negative 1? Oh, no, because there's a minus sign here. It's b is equal to 1. So b is equal to 1. Okay, and then c is equal to 3. Okay. So now I'm going to figure out my vertex. My vertex has to be B and C together, so it's 1, 3. I'm going to plot that point. 1 from the center up 3. Plot my point here. Okay. Then I have my A. I'm going to make it a fraction. Since A is equal to 2, I can make positive A by putting a positive 1 underneath. And we're going to do a negative A by taking 2 and putting a negative 1 underneath. Okay. From my vertex, doing positive A now. I'll use green to represent that. Up 2 over positive 1. There should be a point here. Up 2 over positive 1. Okay? I'll use a different color I'll use blue for the negative A. Okay? I'm going to go up 2 over negative 1. And I'm noticing it's symmetrical. Awesome. Then I'm going to graph my points. And I'm done. Okay? So this is very similar to lines, except that it's absolute value. It's going to look like a V. Okay? Questions on numbers 1 or 2? The goal for today is the graph. That's all you have to do today is graph. Okay? Tomorrow we're going to do some more exploring on this, but for today this is the goal. Questions? Okay, cool. So it's Monday, or not Monday. It's Wednesday, but I haven't heard you guys talk all week. So let's have 1 start today. Let's have 1s are starting, explaining number 1. If you don't have a 1, let's have a 3 talk in your group. And then once the 1s or 3s are done, let's have a 2 talk for about number 2. Okay? We have 2s in here. Ready, set, and go. Number 3. Okay, number 3. Okay, turn to your neighbor and tell them what A, B, and C are on this. Okay, what's A equal to, everyone? 1. Good. What's B equal to? 3 or negative 3? 3. Good. It's 3, right? Because it's in the form. And then C is? Good. So then what is my vertex, everyone? No. What's my vertex, everyone? It's an ordered pair.
1 over 5.
Okay, I got like 1 over 5, 3 over 5. 3, 5. Thank you. Please be specific, okay? So here you go to 3, 5. Let's go to our iPads. Go right down 3, 5. We're doing this one together, okay? Plotting a point at 3, 5. Make sure you have graph axes on. Okay? Cool. So we know A is 1. So we need to make a positive A and a negative A. So watch up here. This is how we do it. If we know A is 1, let's write down A is equal to 1 one more time in our notebook like this. Ready? And we're going to make one positive numerator, one of them with a positive numerator, and then one of them with a negative numerator. Okay? Does that make sense? That's going to be the best way for you to do this, to make sure you don't make a mistake. Okay, so A is positive. Let's do the first one, starting with my vertex. We're going to go up 1 over 1, because that's a positive A. Up 1 over 1. Up 1 over 1, right? Then we're going to go back to our vertex. And we're going to go up 1, and it says negative 1 that time. We're going to go up 1, then go negative 1 to the left. And up 1, negative 1 to the left. Okay? So I know that was my vertex. Oops. Now we're going to graph. Okay? And yours should look like mine. Okay, so let's see yours. Okay, number 4. Turn to your neighbors, tell them what A, B, and C are. What's A, B, and C? Tell your neighbors. Okay, what's A, everyone? Good. There's a negative sign, so it's going to be negative 1. B is? 1 or negative 1?
Negative.
Good. C is? Good. So what is my vertex on this one?
-1.
Good. -1, -2. Good. So let's plot that. Should be right here. Now we're going to do a positive and a negative A. So we're going to write positive A, negative A, and we're going to write down -1 on each of these. The first one we're going to have a positive denominator. To the second one we're going to have a negative denominator, right? So finish up graphing for me. I'll give you about 45 seconds. Go. And I'm going to check on your work. Okay, look up here. So remember, positive A, we're going to start at the vertex. We're going to go down -1, rise -1, run 1. Eyes up here because some of you made mistakes, okay? So from the vertex, we're going to go rise -1, run 1. So we should have a point here, right here, right? Rise -1, run 1. And I'm going to keep doing this down my graph. Okay? Make sense? And then we're going to go back to the vertex. We're going to go to the next one, which is we're going to rise -1, run -1. Okay, so I'll use a different color for this one. We're going to rise -1, run -1. So there should be a point right here. Rise -1, run -1. Okay? Some of you made a mistake here. Do you see where you made a mistake? Yeah? Okay. So fix it. Make sure you fix your mistakes. It's important that you fix them right now. Okay? That's how you do number 4. Next one, number 5, okay? Before we start number 5, turn to your neighbors and tell them, what do you notice about this before we even start graphing? What do you notice about it?
There's no problem.
There is something wrong with it. What do you notice about it that's different? What do you notice that's different between this one and, let's say, number 2?
This one doesn't have an equation.
Okay. So what's wrong with it? I heard someone say back there. Jonathan? Good. Do you all see this 2 here in front of the x? Do you all see this? Is this in the right format of y equals a times x minus b all plus c? Does it look like that? Does that look correct? No, because in my standard form, I should have a 1 in front of this x, right? But over here I have a 2. Do you see that?
Yeah.
So I have to get rid of that 2. Check this out. Eyes up here. This is a step you have to do sometimes. Eyes up here. iPads down. iPads down. Okay, so I don't like this 2 here. How do I get rid of it? I need to factor it out. So we're going to factor out a 2 because I don't want a 2 there. Okay? So when I do that, we're going to go y equals, take out a 2, and then I ask myself, 2 times what is 2x, everyone? 2 times what is 2x? Oh, wow. Okay, I'm hearing like 5 answers. 2 times what is 2x? Okay, good. I heard people say 2. I heard people say 2x. Okay, good. 2 times what is positive 4?
2.
Positive or negative 2?
Positive.
Good. Okay, now that... Is there a 1 in front of the x now?
Yeah.
Good. So is it in standard form?
Yeah.
Good. Now finish this problem up with your group. Okay, go. iPad's back out. You could get on it. Go. Okay, so up here, that was the hardest part of this problem, was to factor out the 2, okay? So, but now that we have a standard form, what's our A, everyone?
2.
A is equal to 2. B?
Negative.
Negative what?
2.
1 or 2?
Negative.
Negative 2, thank you. Okay, C?
0.
Good, so that means our vertex is at negative 2, 0. Okay, so I'm going to go to negative 2, 0, plot a point. Okay, I saw a lot of you did this. Okay, now, A, here we go. This is where people get confused. There, I saw a lot of different answers. Positive A, remember we're going to do positive A, and we're going to do, since it's positive A, I'm going to put a positive 1 in the denominator. Negative A, I'm going to take the same 2, leave it in the numerator, and put a negative 1 in the denominator. Y'all see that? Okay, so then I'm just going to go up 2 over 1 for the positive A, up 2 over 1 for the positive A, up 2 over 1 for the positive A, and I keep doing that across my graph. Going back to my vertex, I'm going to go up 2, negative 1 for negative A. Okay, what do you notice about my graph? Is it, from the first graph, is it more narrow, more wide, or the same? No, there's only 3 options. There's no mid-size. Is it more narrow, more wide, or the same? Look at my original problem, number 1. And now look at number 5. Is it... What did you see? Actually look at number 3. You see number 3 up here?
Narrower.
Okay. Now look at number 5. Is it more narrow or more wide?
More narrow.
Good. More narrow. Good. Okay. Next one, last one. Let's get through this. Okay, number 6. Working with your group. What's wrong with this problem? And then what would you do to start it up? This one's like number 5. Last one. Go. Good. We don't like that 3 here in front of the x, so we have to factor it out. So you should have had this y equals, factor out a 3, open parentheses. 3 times what is 3x? No. X. Thank you. 3 times what is positive 6?
2.
Positive 2. Sorry. So what is our A, everyone?
3.
Good. B?
-2.
C?
-5.
Okay, good. So then our vertex could be -2, -5. Okay. So I'm going to go -2, -5, plot my points. Okay, our A, remember we're going to do a positive A, which means we're going to have a positive 1 in the denominator. And then our negative A will have a negative 1 in the denominator. Okay? Does that make sense? Okay. So now we're going to go up 1, 2, 3 over 1. 1, 2, 3 over 1. Up 3 over 1, right? And I keep doing that across my whole paper because really this graph goes on forever. We're going to do the same thing in the opposite side. Okay. That's it. Now I got a question. I got a question for you. Is this, look at number 3. Do y'all see number 3 up here?
Yeah.
Is number 6 wider or more narrow than number
Narrow.
3?
Narrow.
Why is it more narrow? Predict why. What made it change to be more narrow? What was the variable or the part of the equation that made it more narrow? The A. Good. Why the A, Victor? Okay, Victor's on to something. Why does the A change things? Yes, Christian.
Because it's a bigger number.
Good. It's a bigger number, right? So the numerator is getting bigger, which means it has a bigger rise, right? Does that make sense? Yeah. Okay, good. All right. That concludes the lesson.